You already know about the day the dinosaurs died. An asteroid, a flash of fire, a world plunged into darkness. It's the most famous catastrophe in the history of our planet, but it is not the worst, not even close. Long before the dinosaurs ever existed, tens of millions of years before that asteroid fell, life on Earth suffered a blow so devastating that it makes the death of the dinosaurs look almost gentle by comparison. It was the closest this planet has ever come to being scrubbed completely clean, the closest life itself has ever come to simply ending. We call it the Permian extinction, or more fittingly, the Great Dying, and the numbers behind that name are almost impossible to take in. When it was over, something like 9 out of every 10 species on Earth were gone. Not 9 out of 10 individual creatures. 9 out of 10 kinds of living thing wiped from existence. In the oceans, the devastation was even worse. The living world was very nearly switched off. If the die had rolled just slightly differently, there might be nothing here at all. No forests, no animals, no you. And here is the part that will stay with you. This wasn't a single sudden blow. There was no one terrible instant, no asteroid slamming down out of a clear sky. The Great Dying was slow. It unfolded over a long, agonizing stretch of time as the planet turned against the life it had nurtured, step by step, system by system. The air became a weapon. Then the oceans became a weapon. Then the land itself became a weapon. A living, thriving world was taken apart piece by piece, and almost everything on it was killed. Over the next 40 minutes, we are not just going to learn about this catastrophe. We are going to live through it. We are going to stand in the world of the Permian on its last good day, and then watch, step by step, as everything falls apart. We're going to follow the killing from its very first spark, through the poisoning of the sky, into the death of the seas, across the collapse of the land, all the way down to the moment when life hung by the barest of threads. This is the story of how a planet almost died. And it is, in a strange way, also the story of why we are here at all. If you want to walk through the end of the world with me, from the last living day to the very bottom of the catastrophe, make sure you're subscribed before we begin, because this is a descent into the darkest chapter our planet has ever known, and I want you with me the whole way down. So let's begin where all of this began. Not with the disaster, but with the world before it. Because to feel the weight of what was lost, you first have to see what was there. Picture the Earth a little over 250 million years ago, in the time we call the Permian period. It is a living, breathing world, but it would look deeply strange to your eyes. For one thing, the map is all wrong. There are no familiar continents scattered across the globe. Instead, almost all the land on Earth is fused together into a single, gigantic supercontinent, one enormous mass of land stretching from near the top of the planet to the bottom. We call it Pangaea, one vast connected world surrounded by one vast connected ocean. And this world was full of life. Not the life you'd recognize, not yet. This was before the dinosaurs. The land was ruled by other creatures, strange and ancient. There were sprawling reptiles and amphibians. There were the ancestors and relatives of mammals, our own distant forerunners, some of them big, lumbering plant eaters, others sharp-toothed hunters. Some of these creatures had tall sails of skin along their backs. Others burrowed or lurked near water. It was a rich, complex cast of animals, an entire chapter of evolution that most people have never even heard of, all playing out across the plains and forests and swamps of the great supercontinent. And the seas. The Permian oceans were arguably even more spectacular than the land. They teemed with life in astonishing variety. There were vast reefs, though not built by the corals we know today, but by other ancient reef-building creatures. There were strange armored fish and coiled-shelled creatures drifting through the water. The seafloor crawled with life. Trilobites, those ancient creatures that had survived for hundreds of millions of years, still scuttled across the bottom. The oceans were a crowded, thriving, dazzling world, the product of billions of years of evolution, packed with creatures that had endured through age after age. And take a moment to really appreciate these Permian creatures, because they deserve to be remembered, not just as victims. This was one of the great ages of life before the dinosaurs, an entire world that rose, flourished, and was almost completely erased. The dominant land animals of this time were not dinosaurs at all, but a remarkable group that included our own distant relatives. Some were massive, heavy-bodied plant eaters, lumbering across the landscape in herds, cropping the vegetation. Others were fearsome predators with powerful jaws and blade-like teeth, the top hunters of their day. There were creatures with enormous sails rising from their spines, structures that may have helped them warm up in the morning sun or cool down in the heat, or display to one another. There were squat, wide amphibians the size of crocodiles, lurking in the swamps and rivers. This was a fully realized world, with its own kings and its own hierarchies, its own predators and prey, every bit as intricate and alive as the natural world of today. These animals had inherited a planet that had already survived earlier hard times, and they had built something magnificent upon it. None of them had any way of knowing they were living in the final act. This was the world on its last good day, a full living planet, both on land and in the sea, humming with a diversity of life built up over unimaginable spans of time. If you had stood on the shore of Pangaea then, looking out over that ancient ocean, you would have had no reason to think anything was wrong. The world was old and stable and alive, and that is exactly what makes what came next so chilling. Because far away in the north of that supercontinent, in a region we now call Siberia, the ground was about to crack open, and what came pouring out would begin to kill the world. The murder weapon in the Great Dying was not an asteroid from space. It came from inside the Earth itself. In the region we now call Siberia, the ground split open and the planet began to bleed. But you have to throw away the picture you probably have in your head of a volcano. Forget the cone-shaped mountain with a neat crater at the top, erupting for a few dramatic days. What happened in Siberia was something on a completely different scale, something almost beyond imagining. Enormous cracks tore open across the land, not in one spot, but across a vast region. And out of those cracks, lava didn't so much explode as pour. It flooded out across the landscape in immense sheets, layer upon layer, burying an area of staggering size under molten rock. And this didn't happen over a few days or years. It happened on and off for an incredibly long time, possibly hundreds of thousands of years or more. Eruption after eruption after eruption, flood after flood of lava, until an area larger than many entire countries was drowned in volcanic rock, in places kilometers thick. We call these formations the Siberian Traps, and they represent one of the largest volcanic events in the entire history of our planet. A wound in the earth so vast it's hard to even picture. To grasp the scale of the Siberian Traps, it helps to compare them to the volcanoes we know today. When a single large volcano erupts in modern times, it can disrupt weather across a whole hemisphere for a year or two, cooling temperatures, ruining harvests, coloring sunsets around the world. That is the power of one eruption. Now imagine that kind of volcanic output, but not for a year or two. Imagine it continuing, in pulse after pulse, for a span of time so long that it dwarfs the entire history of human civilization many times over. The Siberian Traps were not one eruption, but countless eruptions, playing out across an enormous region over an immense stretch of time, laying down layer after layer of volcanic rock until the accumulated pile was, in places, kilometers deep. If you could travel back and stand at the edge of that volcanic province, you would see a hellscape stretching to the horizon, glowing rivers of lava, choking clouds of ash and gas, the ground itself split and steaming. And this was not a brief nightmare. It was the state of that part of the world for an almost unimaginable length of time, a wound that would not close, bleeding poison into the sky the entire while. And the location, as it turned out, could hardly have been worse. The rock that the lava forced its way through was not empty stone. It was ground rich in buried carbon, packed with the fossilized remains of ancient life and vast deposits of coal, along with other volatile materials sealed underground over eons. When the searing magma pushed up through all of that, it was like setting a match to a buried fuel supply of continental scale. The heat cooked and burned these deposits, releasing their carbon and their poisons, and driving them upward into the atmosphere on top of everything the eruptions were already producing. It was a cruel multiplier. The same event that was flooding the surface with lava was also reaching down, unlocking ancient stores of carbon and hurling them into the sky. The planet was being poisoned by its own buried past. But here is the crucial thing, the thing that turns a regional disaster into a global apocalypse. The lava itself was not the main killer. Yes, it destroyed everything in its path, but the direct reach of the lava was limited to that one part of the world. The real weapon was invisible, because when you tear open the earth on that scale and pour out that much molten rock over that long a time, you release something far more dangerous than lava. You release gas. Titanic quantities of gas belched out of the planet's interior and pumped into the atmosphere year after year, century after century. And it gets worse because of where in the earth this happened to erupt. As all that molten rock forced its way up and out, it didn't just release the gases it carried on its own. It also burned through and cooked vast deposits buried in the ground, including enormous reserves of coal and other carbon-rich material that had been locked away underground. Setting fire to all of that released even more gas, even more poison, into the sky. The eruption wasn't just a volcano. It was a machine for injecting colossal amounts of carbon and toxic gases into the atmosphere of the entire planet, and it ran for an unimaginably long time. So picture what's happening now in the world we just walked through. For a while, in most places, life goes on. The creatures of Pangaea are living their lives unaware. But far to the north, the sky has begun to change. Enormous volumes of gas are pouring into the atmosphere. Carbon dioxide, the powerful heat-trapping gas, is building up. Other poisonous gases are being released as well. The composition of the very air of the planet is beginning to shift, slowly at first, then relentlessly. The Earth is being fitted, invisibly, with the mechanism of its own destruction. And nothing alive has any idea what is coming, because the terrible genius of this catastrophe is that it didn't kill directly. It didn't need to. It simply changed the air. And by changing the air, it set off a chain reaction, a cascade of consequences, each one feeding the next, that would sweep across the whole planet and dismantle the living world from the top down. The first link in that chain was the sky itself. The atmosphere that every living thing depended on was about to turn into a slow, spreading poison. And once the air itself became the enemy, there was nowhere left to hide. The first great weapon unleashed on the Permian world was heat. All that carbon dioxide pouring into the sky did what carbon dioxide does. It trapped the sun's warmth. It acted like a thickening blanket wrapped around the entire planet, holding in heat that would once have escaped. And as the gas kept pouring out, year after year, that blanket grew heavier, and the world grew hotter. Not by a little, by a lot. The global temperature climbed and climbed into a scorching, brutal greenhouse world, far hotter than the comfortable planet the Permian creatures had evolved to live in. Think about what a rise like that does to living things. Every creature, every plant, is adapted to a certain range of conditions. Push the temperature far beyond what they can handle, and they begin to fail. On land, the heat became punishing, especially across the vast interior of the supercontinent, far from the cooling influence of the sea. Regions that had been livable turned into blistering, hostile zones. And the heat was only the beginning, because the changing atmosphere brought other horrors with it. The gases pouring from the Siberian eruptions didn't just warm the planet, they poisoned the sky in other ways. Some of them reacted in the atmosphere to create acid, which fell back down as acid rain. Imagine rain that stings and burns, falling across the land, damaging the plants it lands on, leaching into the soil, poisoning the rivers and lakes. The forests of the Permian, the great stands of ancient vegetation, began to suffer and die back under the assault of heat and acid and a changing atmosphere. And when the plants die, everything that depends on the plants is in terrible trouble. Because plants are the foundation. They are the base of nearly every food chain on land. They are what the plant eaters eat, and the plant eaters are what the meat eaters eat. Pull the plants out from under an ecosystem, and the whole structure begins to collapse from the bottom up. As the Permian vegetation withered under the poison sky, the herbivores that fed on it began to starve. And as the herbivores died off, The predators that hunted them lost their prey and followed them down. The land-based world was starting to come apart, not because the lava reached it, but because the air above it had turned hostile, and the poison in that air was rippling through every living system. And there's a cruel detail here that made the heat even deadlier. As the planet warmed, some of the natural systems that might have pulled carbon back out of the air and cooled things down were themselves breaking under the strain. The living world has ways of regulating itself, of balancing the atmosphere over time. But those balancing systems were being overwhelmed. Too much gas, too fast, for too long. The planet's ability to heal itself was being smashed by the sheer scale and speed of what was being unleashed. The warming didn't correct itself. It fed on itself, and it accelerated. And here is what makes the warming of the Permian so instructive and so frightening. It was not just that the world got hot, it was how the heat moved through the whole system, triggering one failure after another. A warmer world holds more moisture in some places and bakes others into desert. Weather patterns that life had depended on for ages shifted or broke down. The great seasonal rhythms that plants and animals had timed their lives around no longer arrived when they should. For creatures finely tuned to a particular climate, this was disorienting and deadly. They could not simply pack up and move fast enough to keep pace with a world changing around them, and even if they tried, the poisoned, overheated conditions often waited for them wherever they went. There was increasingly no cool refuge to flee to. The heat was everywhere. And consider the special vulnerability of the tropics, the warm belt around the middle of the planet. Life in these regions was already living close to the upper limit of the heat it could tolerate. Push the temperature up across the whole globe, and it is these tropical zones that cross the threshold first, becoming too hot to sustain the creatures adapted to them. Some parts of the Permian tropics may have become almost uninhabitable for many forms of life. Dead bands across the middle of the world, where the heat simply exceeded what living tissue could bear. Life was squeezed, pushed, and cooked, its options narrowing with every passing century as the greenhouse tightened its grip. So by now in our journey through the end of the world, the sky has become an enemy. The air is thick with heat-trapping gas. The rain burns. The temperature is climbing toward levels that life cannot bear. The forests are dying, and with them, the food chains of the land. It is already a catastrophe. And yet, remarkably, this is not where the Great Dying did its worst work. Because as bad as things were becoming on land, something even more complete, even more total, was beginning to happen in the one place that had always been the great stronghold of life on Earth. The oceans, the seas that had cradled life for billions of years, were about to become the deadliest place on the entire planet. And what happened down there is the heart of this whole catastrophe. The oceans should have been a refuge. Water changes temperature slowly. The sea is vast and deep and buffered against the chaos of the land. If anywhere could ride out the disaster, surely it was the deep blue ocean. But the exact opposite turned out to be true. The oceans didn't shelter life from the Great Dying. They became the very center of it. The sea suffered the most complete devastation of all, and to understand why, you have to understand what heat does to water. The first blow was warming. As the atmosphere heated up, the oceans absorbed that heat, and the seas grew warmer, especially at the surface. And warm water carries a hidden danger, a chemical one. Cold water can hold a lot of dissolved oxygen, the oxygen that sea creatures need to breathe. But as water warms, it loses its ability to hold that oxygen. Warm water simply cannot carry as much. So as the Permian oceans heated up, they began, quite literally, to suffocate. The dissolved oxygen that all that marine life depended on started to drain away, and vast stretches of the sea began turning into dead zones, regions where there was simply not enough oxygen left to breathe. Picture what that means for the creatures living there. Fish, shelled animals, the crawling life of the sea floor, the reef builders, all of them need oxygen dissolved in the water to survive. And now that oxygen is vanishing. Across huge areas of the ocean, and reaching up from the depths toward the shallows, the water became starved of oxygen. The sea creatures were being smothered in their own home, unable to breathe, in an ocean that was turning from a place of life into a vast, spreading zone of suffocation. This loss of ocean oxygen is one of the great killers of the great dying, a silent, invisible strangling of the seas. And there is one more dimension to all of this that is easy to miss but crucial to understand, and that is the question of speed. Extinctions, in a sense, are always happening in slow motion. Species come and go across the long ages of the Earth. What made the Great Dying so uniquely devastating was not only how much it killed, but how fast, in geological terms, it did so. Life can adapt to almost anything if it has enough time. Given long enough, creatures evolve, ranges shift, ecosystems reorganize, and the living world flows around a challenge like water around a stone. But when a change comes too quickly, faster than evolution and adaptation can keep pace, there is no time to adjust. Organisms are simply overwhelmed before they can respond. And the Permian catastrophe, for all that it unfolded over a long stretch by the standards of a human life, was brutally fast by the standards of the planet. The carbon went into the sky faster than the world could absorb it. The temperature climbed faster than life could migrate. The oceans changed faster than their inhabitants could adapt. It was the combination of enormous scale and, relatively speaking, terrible speed that made it the worst extinction of all time. The world was not given the one thing that might have saved it: time. But the warming and the suffocation were only part of the assault on the ocean. Remember all that carbon dioxide flooding into the atmosphere? The oceans absorbed a great deal of it, and when carbon dioxide dissolves into seawater, it makes that water more acidic. So the seas didn't just grow warm and starved of oxygen, they also began to turn acidic, their basic chemistry shifting into something hostile to life. And that acidification struck with special cruelty at some of the most important creatures in the sea, the ones that built their shells and skeletons out of minerals drawn from the water. Think of all the ocean life that depends on hard shells and structures, the shelled creatures, the reef builders. They construct their bodies and their reefs from materials that dissolve more easily in acidic water. As the seas grew more acidic, it became harder and harder for these creatures to build and maintain their shells and skeletons. The great reefs of the Permian, those magnificent underwater cities that had teemed with life, fell silent and collapsed. Reef ecosystems, which support enormous webs of life, simply came apart. And the creatures that depended on building hard structures found the very chemistry of the ocean turning against their ability to exist. There is another sinister piece to the ocean's death, one that turned the sea itself into something monstrous. In a warm, oxygen-starved ocean, the ordinary life that thrives on oxygen dies back, but other kinds of life, ancient microbes that do not need oxygen, can flourish in its place. And some of these microbes, as they go about their lives in oxygen-free water, produce toxic chemicals as waste. In the stagnant, airless depths of the dying Permian Sea, these microbes may have bloomed and spread, filling the water with poison, and in some scenarios, releasing foul and toxic gases that could bubble up out of the ocean and drift across the land. Picture that for a moment. The sea not merely dead, but actively churning out poison, its chemistry hijacked by the only things that could still thrive in it, turning the ocean into a source of toxins rather than a haven of life. The cradle of life had not just failed. It had, in the worst affected regions, become an engine of death in its own right. And the collapse of the reefs deserves special attention, because reefs are not just pretty structures. They are among the richest habitats on the entire planet. A reef is a city. It provides shelter, hunting grounds, nurseries, and homes for a staggering number of species, far more than the open water around it. When the Permian reefs dissolved and crumbled under the acidifying, warming, suffocating conditions, it was not just the reef builders that died. It was the entire teeming community that depended on the reef for survival. Whole ecosystems that had taken ages to assemble, layered and interdependent, collapsed together in a cascade. And reefs, once destroyed on this scale, do not simply spring back. For a very long stretch after the Great Dying, the seas of Earth were left without proper reefs at all. A silent, structureless emptiness where some of the most vibrant habitats in the world had once flourished. So now stack it all together and feel the full horror of what the Permian Ocean had become. The water was too hot. The oxygen was disappearing, suffocating the creatures that remained. The chemistry was turning acidic, dissolving the shells and reefs that life had built. Three catastrophes at once, all striking the same waters, all feeding into each other, all driven by the same relentless source, the gases pouring from the dying planet. The ocean, the ancient cradle of all life on Earth, had been transformed into a warm, airless, acidic grave. And in that grave, the majority of all marine species on the planet were wiped out. This was the epicenter of the Great Dying. And yet the catastrophe was still not finished, because back on land, the cascade of death was reaching its terrible climax. Back on the land, the world was coming apart in a chain reaction that fed on itself. We left the land with its forests dying and its food chains starting to collapse. But as the catastrophe deepened, the death on land accelerated into something even more complete, and it did so through a series of vicious cycles where each disaster made the next one worse. Start with the plants. As the great forests and the ground-covering vegetation died back under the heat and the acid and the poisoned air, something crucial was lost, something most people never think about. Roots. Plants and their roots are what hold the soil of the world together. They anchor the land. They keep the soil in place. And when the plants across vast regions died, the soil that their roots had held began to wash away. Rains and rivers stripped the bare, dead land, eroding the soil and flushing it away, choking the rivers with mud and debris. The very skin of the living land, the fertile soil built up over ages, was being torn off and lost. And once the soil is gone, new plants cannot easily grow back, which means the land stays barren, which means more erosion. A downward spiral feeding itself. And all of this was happening under that punishing greenhouse heat. In the heart of the supercontinent, far from any sea, temperatures could become almost unbearable. The interior of Pangaea may have turned into a vast, deadly, scorching wasteland, too hot and too dry and too poisoned to support much of anything. The creatures that had once thrived there, the sail-backed reptiles, the mammal ancestors, the amphibians, the whole rich community of Permian land life, were pushed past the edge of what they could endure. Species after species vanished. The animals starved as their food disappeared, roasted in the heat, sickened in the poisoned environment. The complex web of life that had taken so long to build was unraveling thread by thread, and each broken thread pulled others down with it. This is the true nature of a mass extinction. It is not one clean blow. It is a collapse of everything at once, a cascade where the death of the plants kills the plant eaters, and the death of the plant eaters kills the predators, and the loss of the soil prevents recovery, and the relentless heat and poison make sure nothing can catch its breath. Every support that living things leaned on was knocked away, one after another, until there was almost nothing left holding the living world up. On land and in the sea together, the planet was being emptied of life. And so we arrive at the very bottom, the lowest point in the history of life on Earth. Picture the world now, at the worst of the Great Dying. The seas are warm, acidic, and largely dead, vast stretches of them silent and empty and starved of oxygen. The land is scorched and eroded, its forests gone, its soil washing away, its animals reduced to scattered, struggling survivors in a hostile world. The sky is hazed with the products of the eruptions. The reefs are gone. The great diversity of the Permian, all those countless forms of life, has been slashed to a fraction of what it was. Something like 9 out of every 10 species, gone. This is as close as our planet has ever come to sterilizing itself. Life is still there, but barely, hanging on in scattered pockets, clinging to a world that has done everything possible to kill it. For a moment, on the whole face of the Earth, life itself seems to hang in the balance. And it is difficult, standing in the comfortable present, to truly imagine the silence of it. We are used to a world that is loud with life, birdsong, the hum of insects, the rustle of countless creatures going about their existence. Strip 9 out of 10 species from the world, gut the oceans, empty the forests, and what you are left with is a quiet, unlike anything in the living memory of the planet. Vast landscapes with almost nothing moving across them. Seas where the crowded, colorful communities of before had dwindled to a scattering of survivors in poisoned water. The Great Dying was not only a catastrophe of numbers, it was a catastrophe of silence, a hush falling over a world that had, for hundreds of millions of years, been overflowing with life. That is perhaps the hardest thing to picture, and the most haunting, how close the living planet came to falling almost completely still. And that is the darkest moment in this entire story. But it is not the end of it, because life did not go out. Against everything the planet had thrown at it, against heat and acid and suffocation and starvation and poison, life held on. And what happened after the bottom is, in its own way, just as astonishing as the catastrophe itself. Because from that emptied, broken, nearly sterile world, life came back. It took a very long time, far longer than recovery from other extinctions, because the damage had been so deep and the world had been so thoroughly wrecked. For a long stretch afterward, the planet remained a harsh and impoverished place, slowly healing. But the survivors, the hardy few that had made it through the needle's eye, began to spread and adapt and diversify once more. Life crept back out across the land and refilled the seas. Empty world became living world again, over millions of years, rebuilt from the handful of creatures tough enough or lucky enough to endure the worst day the planet ever had. It is worth pausing on just how strange and haunting the recovery world was, the world immediately after the worst had passed. For a long time, the planet did not bounce back. Instead, it lingered in a kind of impoverished twilight. The rocks from the period just after the extinction tell a bleak story. In many places, the rich variety of life that fills a healthy world is simply absent. Instead, certain hardy, opportunistic survivors spread across the emptied planet in enormous numbers, unchallenged, because so many of their competitors and predators were gone. There were times and places where a single tough species dominated vast regions, a monotonous world, the biological equivalent of weeds taking over an abandoned lot. A healthy ecosystem is diverse and balanced. The post-extinction world was neither. It was a thin, ragged, simplified version of a living planet, and it stayed that way for a startlingly long time, as if the Earth itself were stunned, struggling to rebuild what had been lost. And that slow recovery is one of the most sobering parts of the whole story. Other mass extinctions in Earth's history were followed by relatively quicker rebounds. But the Great Dying had cut so deep, had damaged the living systems of the planet so severely, that the healing took far longer. It was not a matter of a few thousand years. It was a matter of millions upon millions of years before the world regained anything like its former richness. The wound was so profound that the scar took an age to fade. And that tells us something important, something we will come back to. When you damage the living systems of a whole planet badly enough, recovery is not quick, and it is not guaranteed to look anything like what came before. And here is the part that should send a shiver down your spine, because it connects that ancient apocalypse directly to you. Among those survivors were the ancestors of creatures that would go on to inherit the earth. In the emptied world left behind by the Great Dying, with so many old forms of life swept away, new opportunities opened up. And out of the aftermath, in the ages that followed, rose the dinosaurs, who would rule the planet for a vast stretch of time. But also among the survivors and their descendants were the ancestors of mammals, the small, tenacious forerunners of a lineage that would, hundreds of millions of years later, lead all the way to us. If the Great Dying had been just a little worse, if those particular survivors had not made it through, the entire story of life afterward, dinosaurs and mammals and eventually human beings, might never have happened at all. We exist in part because life refused to die completely on the worst day it ever faced. Let's dwell on those survivors for a moment, because who lives and who dies in a catastrophe like this is not simply a matter of strength. The mightiest, most dominant, most impressive creatures of the Permian were often exactly the ones that vanished. Being big and successful in the old world was no protection at all when the world itself changed. Instead, survival often favored the small, the flexible, the unfussy, the creatures that could tolerate a wide range of conditions, eat many different things, shelter in burrows, endure hard times on very little. In a stable world, these unremarkable creatures might never have stood out. But when everything collapsed, it was exactly these qualities, toughness, adaptability, modest needs, that carried certain lineages through the needle's eye while their grander neighbors perished. There is a lesson in that about what truly matters when the ground shifts beneath a living world. And it is not size or dominance, it is resilience. And it's worth being clear about the strange debt we owe to this disaster. The world before the Great Dying was not a world heading toward us. It was dominated by lineages that, had they continued to flourish undisturbed, might have kept the planet on a completely different course. It was the catastrophe itself, the great clearing away of the old order, that opened the door for what came next. In the emptied landscape left behind, the surviving lineages radiated into all the roles that had suddenly fallen vacant. And over the following stretches of deep time, this reshuffling ultimately set the stage for the age of dinosaurs, and, running quietly alongside them, for the long, patient rise of the mammal lineage that would one day include us. It is an unsettling thought. The worst thing that ever happened to life on Earth was also, in a sense, one of the great turning points that made our own existence possible. We are here not in spite of the end of that ancient world, but partly because of it. So why does a catastrophe from 250 million years ago matter now? Because the Great Dying is the most extreme example we have of what happens when the planet's climate is pushed too far, too fast. The core of that ancient disaster was a massive, rapid release of carbon into the atmosphere, and the cascade of warming, acidifying oceans and collapsing ecosystems that followed. It is a warning written into the rock, a record of just how fragile the living balance of a whole planet can be, and how a change in the air can ripple outward until it touches every corner of the world, land and sea alike. The Permian world had no idea what was happening to it. We have the enormous advantage of being able to look back and understand. The rocks remember what happened, and they are telling us a story we would be very wise to hear. That is the real reason scientists study this ancient event so intently, and why it is far more than a piece of grim trivia from the deep past. The Great Dying is the closest thing we have to a controlled experiment in what happens when a huge amount of carbon enters the atmosphere in a geological blink. It shows us the shape of the cascade, warming air, then warming, acidifying, oxygen-starved oceans, then collapsing ecosystems on land and sea alike. It shows us that these systems are connected, that the sky and the seas and the soil are all threaded together, so that a blow to one becomes a blow to all. And it shows us that recovery, when the damage runs deep enough, is measured not in lifetimes, but in ages. The Permian world stumbled into this blind. We are the first generation of living things with the ability to read the warning it left behind in the stone. Because in the end, the Great Dying is not just a tale of destruction. It is the story of how close life came to ending, and how, against all odds, it endured. It is a reminder that the living world, for all its richness and resilience, is not indestructible, that it rests on a delicate balance that can be broken. And it is a testament to the sheer, stubborn persistence of life itself, that even after the worst catastrophe this planet has ever known, even after 9 out of 10 species were swept away, something survived and rebuilt, and eventually gave rise to everything alive today, including us. We are the descendants of the survivors of the end of the world, and that is worth remembering the next time you wonder how fragile or how tough life on this planet really is. If this journey through the end of the world stayed with you, tell me in the comments which part hit you hardest, and subscribe, because the story of our planet is full of these moments that shaped everything that came after, and we are going to keep uncovering them one by one. The past is not silent. It speaks through the rock if we are willing to listen, and this is one of the loudest warnings it has ever left us.